Beneath the velvet canopy of the cosmos, humanity stands at the threshold of something extraordinary. The quiet hum of rocket engines, the fiery brilliance of ignition, the breathless pause before the void swallows a vessel whole. This isn't science fiction. It is our future, our now. As Earth spins on, orbiting its familiar star, a new race pulses just beneath our feet, not in the soil, but in the silence between planets. While NASA has long held the scepter of celestial ambition, it is no longer alone. Around the globe, space agencies, private pioneers, and visionary engineers are carving their initials into the stars. These aren't just missions, they're humanity's whispered prayers to the universe, a collective cry of curiosity echoing across the void. If this resonated with you, don't forget to like, subscribe, and share with someone who needs to hear this. The year 2221 opened not with hesitation, but with a quiet, thrilling defiance. Perseverance, the name could not be more fitting, pierced the Martian skies like a silent arrow, descending through an alien atmosphere, battered by flames, then kissing the dust of a foreign world. It was not just a robot. It was a promise fulfilled, a declaration to the cosmos. We are not afraid to wonder. But what did Perseverance truly seek? Not gold, not conquest. It searched instead for whispers in the soil, ancient echoes in clay, remnants of something microscopic yet magnificent. Life. Fossilized traces, mere ghostly outlines, of microbial beings that once might have swam through rivers long vanished. Where it landed, in the Jezero crater, was once a delta, a Martian cradle of possibility. Now, it is a crime scene of time, waiting for Earth's forensic lens to uncover truths buried for billions of years. And yet, this rover did not come alone. Alongside it rides humanity's hopes, meticulously packed into titanium containers and carbon fiber dreams. Perseverance is not merely collecting data. It's laying breadcrumbs for those who will come after. Humans in spacesuits, red dust in their boots, standing where no human has stood before. From the quiet control rooms at JPL to the buzzing classrooms of future astronauts, the implications are seismic. Not only is this rover our scout, but it is our handshake across time, with a version of ourselves yet to exist. Every drilled core sample left behind on Mars is a signature written in Martian stone. We were here, and we are coming back. But not all eyes remained on Mars. Half a world away, the relentless gaze of China's space program sharpened into brilliant focus. In 2020, they shocked the world, touching down on the far side of the moon, a place so veiled in mystery it once existed only in science fiction. Their Chang'e 4 mission made the unseeable visible, landing softly in the South Pole Aitken Basin, the oldest, deepest crater we know on the moon. This wasn't just science, it was statement. In 2022, China doubled down on their ambitions. A new space station, smaller than the ISS but formidable in its own right, began to form in Earth's orbit, a modular testament to national pride and technological prowess. Controlled from Beijing Aerospace Command, it represents more than orbital occupancy. It's a prelude to a decade of breathtaking ventures, probes to the moon, rovers on Mars, and the return of Martian soil to Earth. A lunar base gleams faintly on the distant horizon, not as fantasy, but inevitability. These missions, though many miles apart, are tethered by one common thread: the insatiable thirst for cosmic truth. It is no longer enough to orbit our planet, or even land on the moon. The new mantra is bolder: to stay, to mine, to live, to expand. As the stars continue their endless pirouette in the firmament above, we are no longer mere observers. We are dancers ourselves, stumbling, leaping, learning. Preparing for the greatest ballet of all time, humanity's permanent waltz among the stars. The night sky no longer belongs to dreamers. It belongs to the doers. It belongs to us. Return to Luna. The moon beckons. Once more. The stars remember us. They remember our first faltering steps, taken in bulky suits and with trembling voices transmitted across static-filled channels. They remember when, for a brief moment in 1969, humanity touched the heavens. But the moon? She's been waiting longer than that. Ancient, watchful, and luminous, waiting not just for visitors, but for residents. And now, more than half a century after Apollo's final bow, we are going back, not as mere tourists, but as architects of a new celestial chapter. In 2024, NASA's Artemis program will awaken the moon from its long solitude, but this time, it won't just be men etching footprints into dust, it will be women too. For the first time, a woman's boot will meet lunar soil. Her voice will echo through the silence, and her story will ripple through time, like the soft flutter of a flag unfurling in slow motion. The lunar South Pole is the target, a place where shadows are eternal and ice hides in darkness. This ice, molecular memories of comets and eons past, is more than water. It is life support. It is fuel. It is the first block in the foundation of a lunar future. Artemis is not a stunt. It is rehearsal. It is proof of concept for Mars, a way to understand what happens to the human body when time and gravity both let go. What does it mean to live in lunar twilight? To wake not to sunrise, but to the whisper of a million stars overhead? To build, to farm, to survive? The Artemis program seeks those answers, and more. Imagine it, a greenhouse blooming beneath transparent domes, potatoes sprouting in soil laced with lunar regolith, machines humming with harvested solar energy, astronauts huddled in modular habitats, running simulations for Martian journeys, while outside, Earth rises and sets like a sapphire pendulum in a sky of obsidian. Every step on the moon is a data point, every breath, a metric, every heartbeat, a lesson. But there is risk. There is always risk. The moon is not a kind mother. Her surface is sharp with silence, her vacuum unforgiving. The human body, even with all our brilliance and bravado, is still flesh. Fragile, mortal. But our spirit? That's something else entirely. That is the fuel behind Artemis, the audacity to plant a flag not just in dust, but in the annals of history. And as NASA rekindles its cosmic dance with Luna, private industry watches closely. The moon is no longer a flagpole. It is a launch pad, a proving ground for technology, for mining, for habitation. Companies envision robots digging into the soil, extracting helium-3, a potential fuel source for future nuclear fusion reactors. Others dream of moon-based observatories that gaze into the cosmos unfiltered by Earth's atmosphere. And then there's the question of food, not just for nutrition, but for sustainability. Lunar agriculture will be tested, likely beginning with resilient crops, radishes, potatoes, and microgreens. If we can grow life in lifelessness, then Mars becomes less of a fantasy and more of a frontier. But Artemis is not alone in this venture. International collaboration glows bright. The European Space Agency, the Canadian Space Agency, and JAXA, the Japanese Space Agency, have all signed on to contribute modules, technology, and manpower. This isn't just a NASA mission, it's a human mission, a global fingerprint pressed into the powdery plains of an alien world. As the countdown begins, the world watches, eyes wide, breath held, hearts pounding. Because this time, when the engines roar and the capsule soars, it carries more than astronauts. It carries us all. A little girl in Nairobi, staring at the stars from a rusted rooftop. A teacher in Buenos Aires, who turns chalk into dreams. A retired engineer in Kiev, who remembers Sputnik like it was yesterday. Artemis carries them. Carries you. Carries the idea that space belongs not just to the elite, or the privileged or the powerful, but to anyone with eyes enough to wonder. So we return to the moon. Not for glory, not for conquest, but because the stars have called us home. Asteroid gold and corporate stardust. The prospector's wild dream space, for all its elegance and emptiness, is beginning to glitter with the glint of profit. In the vacuum between planets, a new rush has begun, not for territory, but for treasure. This time there are no cowboys on horseback, no picks slung over shoulders. The new frontiersmen wear exosuits, they speak in code and quantum metrics, and they're aiming not for mountain peaks or riverbeds, but for asteroids, those spinning relics of planetary creation that drift silently through the darkness. The Prospector First mission, planned for 2027, Prospector 1 is the brainchild of a private company, Deep Space Industries, that has dared to look at the stars not just as a canvas for exploration, but as a resource, a goldmine of unimaginable scale. And the truth is, they're not wrong. Out there, beyond the warm breath of our atmosphere, float asteroids containing trillions of dollars worth of precious metals, platinum, nickel, rare earth elements that Earth's industries are starving for. A single medium-sized asteroid could hold more wealth than all the banks of Earth combined, enough to crash economies or ignite them anew. But this isn't science fiction. Prospector 1 will be a lean, intelligent scout, designed not to extract, but to analyze. Like an old-world prospector panning for gold, this robotic emissary will journey toward a near-Earth asteroid, land softly on its pockmarked skin, and begin its careful survey. Cameras and spectrometers will scan the regolith, drills will sample the core, and algorithms will begin to hum with the language of value. Is it viable? Is it stable? Is it worth the risk? The mission's success could redefine the very idea of value in a cosmic age. The plan, ultimately, is staggering. To establish a network of autonomous mining machines, to extract ore in zero gravity, to refine metals in orbit, to send back payloads of raw material to be used in construction, technology, even medicine. And eventually, to fuel the stars themselves with the riches of the void. But buried within this promise is peril. Space mining raises more than just dust. It raises questions. Who owns space? Who gets to profit from celestial bodies formed before life even began? If a company claims an asteroid, is it sovereign? What happens when nations, or rival corporations, compete for the same rock? Could conflict erupt not over oil fields or borders, but over a drifting stone 50 million kilometers from Earth? These are not idle speculations. They are legal quandaries still unanswered by international space law. The 1967 Outer Space Treaty declares celestial bodies the province of all mankind, yet interpretation remains murky. Can one claim what one merely touches? Or must one colonize to conquer? Amidst these ethical debates, the technology itself leaps forward. Laser propulsion systems, self-replicating robots, on-site 3D printing stations that could fabricate replacement parts, or even new equipment from asteroid dust itself. This isn't just exploration, it's the genesis of infrastructure in space. We are laying the steel bones of future outposts, future refineries, future empires. And make no mistake, the giants of industry are watching. Jeff Bezos, Elon Musk, and a constellation of tech titans have already invested in the potential of space-based resource extraction. To them, Prospector 1 is a proof of concept, a torch lit on the edge of an endless, profitable darkness. But behind the polished presentations and visionary headlines lies something deeper, something more human. Imagine the child who will grow up not dreaming of being an astronaut, but a space miner. Imagine the first worker to punch a time clock aboard an orbital refinery, the first labor union in space, the first workplace romance amid stars and steel. Humanity will not just visit space, we will work there. We will live there. We will forge relationships, grudges, and legacies under artificial light. And if we are wise, we will remember that even amid the machinery, the algorithms, and the profits, what we mine from space is not only metal, it is meaning. Meaning in pushing boundaries. Meaning in building what was once unthinkable. Meaning in looking up and seeing not just stars, but steps. Prospector 1 may not return with gold, but it will return with something far more valuable. A map to the future. Juice and the frozen giants, searching for life among the moons of Jupiter. Far beyond the warm embrace of Earth, past the red dust of Mars and the rocky boneyard of the asteroid belt, lies a world shrouded in clouds and crowned with storms. Jupiter, the gas giant, the king of planets. Its very name hums with ancient awe. But this time, we are not going to Jupiter for its size, nor for its storms. We are going for its moons, and we're sending juice to get there. No, not the kind that quenches thirst, but something that may finally satisfy our deepest cosmic craving, the search for life. JUICE stands for Jupiter Icy Moons Explorer, a mission led by the European Space Agency, slated to arrive at its destination in 2030, after an 8-year journey through the solar system. On board are a suite of instruments engineered not just to observe, but to listen, to peer beneath ice, to feel for tremors, to taste the chemistry of alien oceans sealed in eternal night. Because here's the extraordinary truth. 3 of Jupiter's largest moons, Ganymede, Callisto, and Europa, are not barren spheres of rock. They are worlds, each holding secrets behind their frozen faces. Europa, the siren of the solar system. Of them, Europa sings the loudest to our imagination. Its surface is a haunted white, scarred by deep ink-black fractures like veins of memory. But beneath that solid crust, a liquid ocean, kept warm by the gravitational embrace of Jupiter's immense pull. A hidden sea, larger than all of Earth's combined. It's a cradle, perhaps, where alien life could stir. Juice will fly close. Very close. Instruments will scan the surface with radar that can peer through ice. Spectrometers will hunt for complex molecules. Magnetometers will feel for the electric currents generated by saltwater oceans sloshing beneath the crust. And perhaps, just perhaps, it will catch a plume, a geyser jetting up from the moon's icy skin, filled with secrets of the deep. This isn't just science. This is a vigil, a mission with eyes open wide, standing at the edge of a sea that has never known light. The giant, with a magnetic soul. Then there's Ganymede, the largest moon in the solar system, even bigger than Mercury. Unlike any other moon, it possesses its own magnetic field, a shimmering aurora generator under Jupiter's shadow. JUICE will do more than fly by. It will orbit Ganymede, the first spacecraft ever to orbit a moon other than our own. What will it find? Ganymede's secrets are layered like a great geological poem: crust, ocean, mantle, core. Some models suggest multiple subsurface oceans, stacked like the tiers of a strange planetary wedding cake. Could life form in such complexity? Could it survive? JUICE seeks to know. Callisto, the ancient and the undisturbed. Last, Callisto, the pockmarked veteran. Unlike Europa or Ganymede, Callisto's face is untouched by time's erasure. Every crater tells a story, every ridge a relic. Yet even here, signs hint at a liquid ocean, a whisper of warmth beneath ancient scars. JUICE will listen, gently, to the pulse of a body billions of years old. And all of this, for what? Not for conquest, not for resource extraction, but for connection. To know we are not alone. To know life could bloom in places we never dreamed it could. To know that water, warmth, and time, those sacred trinity of biological birthrights, exist beyond Earth. To stand in front of a classroom one day, point to a speck on a screen and tell a child, "Here, this is where we found it." Life, not as we know it, but life nonetheless. The cost of curiosity. The JUICE mission is also a testament to patience. Its launch in 2022. Its cruise through space until 2030. Years of darkness, of silence, of deep cold and distant stars. A journey that no human could yet endure, but one a machine can, with unfailing attention and tireless sensors. And then, 3.5 years in the Jovian system. Floating, listening, gathering, understanding. The data it brings back may take decades to interpret, but in every byte will be wonder. In every transmission, possibility. The presence of life doesn't need to come in the form of tentacled beasts or glowing microbes. It may come in chemistry, in patterns, in resonances. JUICE seeks not a creature, but a context. A framework that says, life could happen here. Life might already be here. And if it is, then Earth is not the universe's miracle. It is just its beginning. So we send JUICE. We send it like a message in a bottle flung into the cosmic tide. And we wait, because in that waiting, in that hope, we find the truest essence of being human. To seek what we cannot see. To believe in what we have not yet touched. To find, in the icy hearts of alien moons, the warm pulse of kinship. Lisa, and the whisper of the universe, chasing gravitational ghosts. Before sound, before light, there were waves. Not the kind that crash against shorelines, but the silent undulations of space-time itself. born in the fires of colliding stars and ancient cataclysms. These ripples are not metaphors. They are real. They move through the universe like whispers through silk. And now, humanity is learning to hear them. Enter LISA, the Laser Interferometer Space Antenna, a name that barely hints at the grandeur of its mission: to eavesdrop on the deepest murmurs of the cosmos. A cosmic microphone set adrift in space, designed to detect gravitational waves so subtle they stretch and compress reality itself by less than the width of an atom. These waves are time's fingerprints. Each one carries the signature of an event so cataclysmic, so mind-bendingly massive, that it echoes across galaxies. Black holes colliding, neutron stars tearing each other apart, the death wails of titanic celestial beasts. LISA is slated for deployment in 2034, and when it does launch, it will not be a single satellite, but three, forming an equilateral triangle, each point 2.5 million kilometers apart, dancing together in orbit around the Sun. Connected by laser beams traveling through perfect vacuum, this constellation will become the most sensitive observatory ever conceived. Not for light, but for the shape of reality itself. The need for LISA. Beyond Earth's limits. We already have LIGO on Earth. The Laser Interferometer Gravitational Wave Observatory has proven the concept, capturing the first confirmed gravitational wave in 2015 and opening a new era of astronomy. But Earth is noisy. It trembles with tectonics, vibrates with human motion, and hums with atmosphere. LISA escapes all of it. Suspended in the silence of space, it will detect lower frequency waves that LIGO simply cannot. Those produced by the slow, swirling dance of supermassive black holes before their final embrace. These are the deep bass notes of the universe's symphony, impossible to hear from our planetary stage. Gravitational waves. Echoes of the unseen. Imagine it. Two black holes, each the size of entire solar systems, spiraling together across eons. They approach, they merge, they vanish. And in that final moment, space-time quivers. LISA will feel that quiver, and from those quivers, a new kind of map will be drawn. A topography not of planets and stars, but of events, of energies, of memory. LISA will not show us what the universe looks like. It will show us what it remembers, because gravitational waves cannot be blocked. They pass through stars, through galaxies, through time itself. They are ancient messages traveling unfazed, untouched, until we finally develop the ears to hear them. The technology behind the magic. How does one measure something that stretches space by mere picometers, a size smaller than the atoms in a strand of DNA? The answer is precision beyond imagination. LISA's lasers must remain perfectly stable across millions of kilometers. Its mirrors must float in perfect freefall, isolated from any force other than gravity. Any error, any jolt, vibration, or solar breeze could drown out the signal. And yet, we are building it. We are building it not because it is easy, but because it will allow us to see a universe we've never seen. Because with LISA, we can answer questions so profound, they border on philosophy. How do galaxies form? What lies in the hearts of quasars? Is our understanding of gravity itself incomplete? LISA may even give us clues about dark matter, or about cosmic inflation, the moment after the Big Bang when the universe exploded into being faster than the speed of light. These are not theories anymore. With LISA, they become testable. The poetic significance. There is something haunting about listening to the universe. It's not just discovery, it's communion. LISA does not see stars. It listens for their screams, their sighs, their silent departures. It turns the cosmos into a story of touch and tension, of convergence and collapse. This is not the cold silence of space. It's a song we are just beginning to hear. And as that melody unfolds, we may discover that the universe is not indifferent, that it remembers, that it responds, that it pulses with the same longing we feel when we gaze upward. In LISA, we are building the stethoscope to press against the chest of the cosmos, to feel its heartbeat. And if it beats in rhythms beyond our understanding, we will listen, we will learn, and we will be changed. Starshot to Alpha Centauri, riding beams across the void. What if we could touch the stars? Not in metaphor, not in poetry, but in physics, in steel, silicon, and light. What if we could reach out to our closest stellar neighbor, Alpha Centauri, and knock gently on the door of another solar system? This is not the dream of tomorrow. This is the vision of now. Welcome to Breakthrough Starshot, a project so audacious, so revolutionary, that it collapses the border between science fiction and science fact. And its goal? To send a fleet of tiny spacecraft, no larger than postage stamps, hurtling through space at 20% the speed of light, reaching Alpha Centauri in just 20 years. The catch? There are no engines, no fuel tanks, no rockets, just sails. And light. The dreamers, Hawking, Milner, and Zuckerberg. Behind this celestial dream is a trio of unlikely stargazers. The late Stephen Hawking, physicist and philosopher of the cosmos, Yuri Milner, Russian tech mogul and venture capitalist, and Mark Zuckerberg, founder of Facebook and architect of our digital lives. Together, they formed the Breakthrough Initiatives, a 100 million effort to leapfrog current propulsion technology and create something humanity has never seen. Interstellar probes, small enough to hold in your hand, fast enough to reach another star in your lifetime. These star chips would each carry cameras, sensors, navigation equipment, and communication tools, all miniaturized, all revolutionary. But how do you accelerate something that small to nearly 60,000 kilometers per second? You use a laser. The science of light sails. At the heart of Starshot is a breathtakingly simple yet devilishly complex idea: a light sail. Each star chip is attached to a wafer-thin sheet of reflective material, just a few atoms thick, stretching meters wide. When a powerful laser array on Earth fires a 100-gigawatt beam at this sail, the photons impart momentum. It's like wind in a sail, only the wind is light, and the ocean is a vacuum. The result? Acceleration unlike anything we've ever achieved. Within minutes, the tiny craft will break free of Earth's gravity. Within hours, it will outrun every spacecraft we've ever launched. Within days, it will leave the solar system. In 2 decades, it will reach Alpha Centauri. Alpha Centauri, the next great frontier. This system, just 4.37 light-years away, contains 3 stars: Alpha Centauri A, Alpha Centauri B, and the dim, reddish Proxima Centauri, which just happens to harbor a planet, Proxima b, within its habitable zone. This is not coincidence. This is targeting. If even one of these miniature probes survives the journey, stabilizes, and turns its cameras toward this alien world, we may glimpse the unimaginable: a second Earth, oceans, mountains, atmosphere, or perhaps a whisper of life in the spectrum of a distant sunset. These aren't images from a telescope orbiting Earth. They would be photos taken within another solar system, by something we built with our own hands. The implications stagger the soul. Engineering on the edge of possibility breakthrough. Starshot is no simple endeavor. The challenges are legion. How do you aim a laser precisely enough to hit a sail millions of kilometers away? How do you protect a delicate chip from interstellar dust at a fifth the speed of light? How do you power instruments without a sun nearby? And perhaps hardest of all, how do you transmit a signal from 4 light-years away, using only a wafer-thin antenna and a trickle of harvested energy? The answers are emerging, piece by piece. Advances in nanotechnology, in AI-guided navigation, in solid-state physics. Each development brings the dream closer. And make no mistake, though tiny in size, each star chip is a revolution. Not only in where it will go, but in how we think about exploration. Because if we can send these microscopic scouts to the stars, why not send thousands? Why not seed the galaxy with messengers, each one a herald of human curiosity? We will become a species not just of travelers, but of whispers. The philosophical leap Starshot isn't just about speed. It's about perspective. It's about understanding in our deepest bones that we are not bound to Earth, that we are not spectators in the cosmic theater, but participants. That light, the most ancient, most universal force, can become our vehicle. And beyond that, The philosophical transformation is profound. We may soon know what no human has ever known: the true scale of interstellar space, the reality of other suns, the intimacy of other worlds, not as dots on a chart, but as places, real places. Starshot dares us to believe, not just in physics, but in purpose, not just in calculation, but in courage. A future of beams and boundaries, broken. One day, long after these first chips have faded into the dark, their legacy may ignite a new age. An age of beam ships, driven by lasers, gliding silently between stars. An age when children grow up with postcards from Proxima. An age when the first human ambassador steps out onto the crust of an alien world, turns to the sky, and knows the way home. And it all begins here, with sails of light, and a little push from Earth. The first Martians, humanity's boldest leap. Yet, there are dreams so wild, so colossal, that they take generations to believe in, let alone to build. One such dream has always burned red: Mars. It beckons from the night sky like an ember in the dark, a planet so close, yet so cursed with myth and mystery. For centuries it has teased us, it has frightened us, it has dared us. And now, at long last, we dare back. In the not-so-distant future, 2030 or later, we will witness something that will rewrite the human story. A rocket will rise, a crew will vanish into the black, and months later, on a distant and hostile world, the first Martians, humans born of Earth but reborn on Mars, will step into the silence. And everything will change. From Earth to Mars, the impossible commute. To say the journey is treacherous is an understatement. Mars is not just another stop along the solar route. It is 34 million miles away at its closest approach. That's an 8-month voyage, one way, with no lifelines and no do-overs. No air to breathe, no fields to farm, no native resources to rely on. Only radiation, loneliness, and the cruel indifference of space. But still, we go. Because within that risk lies revelation. The success of this monumental mission will hinge on what we learn from the trailblazers. The Perseverance rover, still tirelessly roaming the Jezero crater. The Artemis astronauts, soon to make the moon their proving ground. Every core sample, every suit test, every moment spent in the punishing emptiness of space is rehearsal for the real act. Landing on Mars, staying on Mars, thriving on Mars. NASA, SpaceX, and international partners all have Mars in their crosshairs. But let's be clear. This is not just another step. This is a leap of mythic proportion. A leap into a world that will kill you if you misstep. A leap into a future where humans become a multiplanetary species. The anatomy of a Martian mission. So what does it take to make a human into a Martian? First, the craft. A spacecraft capable of shielding its crew from cosmic rays and solar flares for nearly a year in transit. Every ounce of protection is paid for in fuel and mass, so innovation must meet efficiency with ruthless precision. Second, the landing. Mars' thin atmosphere is a paradox. Too thin to slow down a heavy lander with air brakes, yet just thick enough to ignite friction. The landing sequence must be a ballet of fire and software, of retro rockets and parachutes deployed in perfect harmony. Third, the base. This isn't a camping trip. It's colonization. Modular habitats will be inflated and buried beneath Martian soil to shield from radiation. Power will come from solar fields or miniature nuclear reactors. Water will be extracted from ice. Food will be grown in pressurized biomes. Every resource must be recycled, every waste repurposed. Because on Mars, nothing is expendable. And finally, the crew. Not just astronauts, but engineers, biologists, medics, psychologists. They won't just explore, they'll build. They'll endure. They'll live. Because to be the first Martians is to become more than explorers. It is to become pioneers of a new humanity. The psychological frontier. Mars may break the body, but first, it will test the mind. Imagine it. 6 people in a habitat the size of a small apartment. No fresh air, no birdsong, no smell of rain. Just red, everywhere. Red soil, red dust, red horizon. The same 6 faces, every day for over a year. The isolation will be profound. The silence, absolute. Earth will be a blue speck hanging in a black sky. Messages will take 20 minutes each way. No live conversations, no real-time support. Every decision will be autonomous, or fatal. And yet, in that silence, something will awaken. In the quiet panic of the first morning. In the breath held as a drill touches Martian rock. In the shared gaze as the first plant sprouts in alien soil. We will remember why we came. Because Mars isn't just the next step. It is the mirror in which we see what we're capable of. The legacy of the first footprints. Whoever those first Martians are, whether American, Chinese, Russian, or a patchwork crew of nations, they will carry all of us with them. They will be the new Armstrongs, the new Gagarins. They will etch their names into textbooks, into monuments, into memory. They will build the first Martian structures. They will mark the first Martian graves. They will give birth to the first Martian generations. Yes, birth. Because if we are to stay, we must grow. We must raise children under a different sky. Teach them a new kind of history, and let them name the valleys and mountains of their world. Not ours. Those children won't be immigrants. They will be Martians. And they will look up at a dim blue star and wonder about the cradle their ancestors came from. They will build their own myths, their own music, their own marvels. This is not the end. It's the genesis. Make no mistake, the road to Mars is littered with hazards. Rockets will fail, crew members will die, plans will falter. But we will go on. Because that is what humans do. We go. We build bridges where there is no river. We throw our hearts across the void and chase after them with our hands. Mars is not the end of exploration. It is the beginning of something far greater. Not a mission, a migration. And when it happens, when the dust settles and the flag is planted, not as a symbol of conquest, but of commitment, we will look at the red planet and say, at long last, we are home. The new space race, billionaires, nation-states, and the fight for the final frontier. There was a time when space was a battlefield of ideologies. The Cold War lit a fuse under the rocket programs of the United States and the Soviet Union. The moon became the ultimate trophy. Sputnik beeped overhead. Neil Armstrong whispered into the lunar silence. But that race ended, not with a bang, but a sigh. Now, a new race begins. And this time, the contenders are not just nation-states. They're billionaires, visionaries, private empires built on algorithms, innovation, and audacity. This is not the space race of the past. This is the space gold rush. And the stakes? Not just glory, but ownership of the final frontier. The Titans, Musk, Bezos, Branson, and the rest. At the center of this high-stakes standoff are three extraordinary, eccentric moguls. Elon Musk, the South African-born architect of SpaceX, has a singular obsession: Mars. His Starship rocket, tall, stainless steel, and shimmering like a rocket straight out of a retro sci-fi novel, is designed to carry 100 humans to the Red Planet. Musk speaks of Mars not as a maybe, but as a mandate. Humanity must become a multi-planetary species, he argues, or risk extinction. SpaceX isn't just building rockets, it's building escape velocity for civilization. Then there's Jeff Bezos, founder of Amazon and head of Blue Origin. While Musk dreams of Mars, Bezos has his eyes on the moon. His vision? Millions of people living and working in space, sustained by off-world industry. Blue Origin's New Shepard rocket has already carried tourists briefly into space, but its ultimate goal is permanent infrastructure, lunar landers, orbital platforms, and eventually, space habitats. For Bezos, space isn't an escape, it's expansion. And Richard Branson, the flamboyant founder of Virgin Galactic, had once hoped to lead the charge. His dream? Suborbital joyrides for civilians, turning spaceflight into a luxury adventure. But in the race to scale and sustainability, Branson has fallen behind. His company now pivots towards satellite launches and commercial services. Yet these three are just the beginning. Rising in their shadows are private entities backed by military contracts, foreign investments, and sovereign ambitions. Startups fueled by cryptocurrency. Governments inspired by legacy. The new space race is not between countries. It's between philosophies. Do we go to space to live or to profit? To preserve Earth or to leave it behind? Russia and China, the sleeping giants, awaken. While the West watches its billionaires build rockets, the East is playing the long game. Roscosmos, Russia's space agency, may have lost its Cold War sheen, but it remains a player. Partnering with private firm Space Adventures, Russia plans to turn decommissioned spacecraft into space taxis, a commercial venture aimed at the ultra-rich. But there's more. In its most ambitious twist yet, Roscosmos has floated the idea of transforming the International Space Station, once a hub of research, into a luxury space hotel, where celebrities sip cocktails above the clouds. China, however, is in a league of its own. With stunning speed and efficiency, the China National Space Administration, CNSA, has become a juggernaut. From their successful Chang'e missions on the Moon to the Mars rover Zhurong, China has established its technological credibility. Its Tiangong space station is fully operational, and its sights are set on a lunar base, created not alone, but in cooperation with Russia. In the East, space is not a dream, it's a strategy. What's really at stake? At first glance, this seems like a thrilling spectacle. Rockets rising, companies competing, flags flying. But beneath the smoke trails and launch countdowns lies a darker reality. This new space race is about control. Control over launch infrastructure. Who can access space and who cannot. Control over resources, from helium-3 on the Moon to platinum-rich asteroids. Control over data. Satellite networks that can shape geopolitics and dominate the internet. And even control over narratives. Who defines the future of humanity? Governments? Corporations? The people? The Moon may one day host bases. Mars may one day be mined. Asteroids may one day carry rare metals back to Earth. But without a clear shared framework, we risk turning space into the next battleground. An orbital Wild West. A frontier without law. The legal vacuum. Currently, space is governed by the Outer Space Treaty of 1967, which declares that no nation may claim sovereignty over celestial bodies. But that treaty was written before private enterprise even dreamed of orbit. It never envisioned a future in which companies would launch hundreds of satellites per year, or in which billionaires would stake claims to planets. So what happens when Blue Origin mines lunar ice? Or when SpaceX plants a Mars base? Or when China stakes a flag at the Moon's South Pole? Who decides what belongs to whom? Who arbitrates conflict? These are questions we must answer before ambition outruns ethics. Because this time, the stakes are global. The endgame. A shared sky or shattered dreams. The new space race can go one of two ways. It can become a collaborative miracle, a moment where humanity unites under a single sky, driven not by profit, but by purpose. Shared research, shared infrastructure, shared dreams. Or it can devolve into a cosmic class war, where the wealthy flee Earth for orbital luxury, and the rest watch from below, left behind in a world they couldn't afford to escape. It is not too late to choose. The stars are not the prize, they are the test. And whether we pass or fail depends not on our rockets, but on our resolve. To go not just farther, but together. Final reflections. The edge of forever. And so we arrive, not at the end, but at the event horizon of our era. A moment suspended between two worlds, the Earth that raised us, and the cosmos that now calls us. From Perseverance drilling into Martian clay to starships racing toward Alpha Centauri on beams of light, we are witnessing the awakening of a species no longer bound to a single planet. We are, truly, becoming interstellar. But amid the rockets and robots, the billionaires and bureaucracies, we must remember what this is really about. It's not about technology. It's about transcendence. The pursuit of space is the purest expression of something ancient and sacred. The need to know what lies beyond the next hill, the next ocean, the next star. It is not conquest. It is connection. A bridge between who we are and who we have the courage to become. Yes, there will be failures. Yes, there will be cost. But the alternative is stagnation. And to stagnate is to fade. The Earth, beautiful and bruised, is not infinite. One day it will change. One day it will end. But our story doesn't have to. Because now, For the first time in history, we can choose to write new chapters. In Martian dust, on lunar plains, among Jovian moons, beneath Alpha Centauri's pale light. This is not science fiction. This is our destiny. So look up, not with fear, but with fire. Because the future is waiting, and it has your name written in the stars. If this journey through the cosmos stirred something in you, if it made your heart beat faster, your mind wander farther, then don't keep it to yourself. Subscribe for more deep dives into the future that's already unfolding. Share this with someone who needs to remember just how big the universe really is, and how small excuses sound compared to rockets. Because whether you're an engineer, a dreamer, a student, or just someone who still looks up when the night is clear, the sky is no longer the limit. It's only the beginning.